Here we're going to look at a Leaving Cert Applied Maths question on the higher level paper, and this came up in 2010 and it's question 1 part B. So here we're told a particle passes P with speed 20 meters per second and moves in a straight line to Q with uniform acceleration. In the first second of its motion after passing P, it travels 25 meters. In the last 3 seconds of its motion before reaching Q, it travels 13/20 of the distance from P to Q. And we're looking to find the distance then from P to Q. So if we represent this information in a diagram, so what we're looking to find is the total distance from P to Q. And if we let that total distance be D. Now, if we travel from P to some point R, we're told that time is 1 second and the distance travelled was 25 meters. We were then told that in the last 3 seconds of its motion, the time taken was 3 and the distance was 13/20 of D. So what this means is that if we want to travel from P to S, that distance would be 7/20 times D. So first of all, we have loads of information when we're travelling from P to R. So we know the time is 1, we know the displacement is 25, and we know the initial velocity is 20. So we should be able to find the constant acceleration. So when we're travelling from P to R, we know the initial velocity is 20, the displacement is 25, and the time is 1. So we should be able to find out what the constant acceleration is. So with these 4 variables, we'll use S equals ut plus a half at squared. So substituting in for u, s and t, we should be able to find out what a is. So 25 will then equal 20 times 1 plus a half times a times 1 to b squared. So this implies 25 is going to equal 20 plus a half a, which implies 5 equals a half a, and therefore the common acceleration a is going to be 10 meters per second squared. So next of all then, if we travel from P to Q, we know the initial velocity is 20. We're calling the total time t and the total distance d, and we know now the common acceleration is 10. So if we then travel from P to Q, the initial velocity is 20, the displacement, we're letting that be d, the total time is t, and we're after working out the acceleration to be 10. So again, with these 4 variables, we'll use S equals ut plus a half at squared. So this implies the displacement is d, and this equals 20 times t plus a half times 10 times t squared, which implies d is going to equal 20t plus 5t squared. So if we label then this equation as equation number 1, and we'll come back to this at a later stage. Our next step then is we'll travel from point P to the point S. Now we know that the distance going from P to S is 7/20 times the total distance d, and we know the total time from P to Q is t, but the time from S to Q was 3, so therefore the time from P to S should be t minus 3. So when we're travelling then from P to S, the initial velocity again is 20, the common acceleration is 10, the time is t minus 3, and the displacement is 7 over 20 times d. So once again, if we use s equals ut plus a half at squared, this implies 7 over 20 d equals 20 times the time, which is t minus 3, plus a half times acceleration, which is 10 times the time, which is t minus 3 squared. So this implies 7 over 20d is going to equal 20t minus 60 plus 5 on t squared minus 6t plus 9. And again, this implies 7 over 20 times d is going to equal 20t minus 60 plus 5t squared minus 30t plus 45. So this gives us 5t squared. We have a 20t minus 30t, which is a minus 10t, and we have a minus 60 and a plus 45, which is minus 15. So if we want to get d in its own, we're going to multiply across by the 20 and then divide everything by the 7. So d will equal 100 t squared minus 200t minus 300 all over 7. And we can label that as equation number 2. So you can see equation number 1, we had d is 20t plus 5t squared, and equation number 2 we had d is 100t squared minus 200t minus 300 all over 7. So because the left hand sides are the same, we can equate the two right hand sides. So this implies then we're going to get 100t squared minus 200t minus 300 all over 7 equals 20t plus 5t squared. And this implies then, multiplying across by the 7, we've got 100t squared minus 200t minus 300 equals 140t plus 35t squared. And if we bring everything to one side, we're going to get 65t squared. Bringing this over, we're going to get minus 340t. We've got a minus 300 equals 0. So if we then divide everything by 5, we're going to get 13t squared minus 68t minus 60 equals 0. And if we factorize this then, we have a 13c and a t, and the factors of 60 we can use then is, we need to get 68, so we have a 6 here, this will give us a 78t, and if we put in a 10 here, this will give us a 10t. So to get a 68, we want a minus 78 and a plus 10t. So we need a minus and a plus. So solving both of these factors, we're going to get 13c plus 10 equals 0, or t minus 6 equals 0. Now the only solution we're interested in is the positive time, so we can ignore the solution here. So therefore the time is going to be 6 seconds. Now that represents the time travelling from P to Q. But we're actually looking for the distance from P to Q. So we can look back and then use either equation number 1 or the equation number 2 which we had. But equation number 1 would be an easier one to use. So equation number 1 then, this is going to imply D is going to equal 20 times 6 plus 5 times 6 to be squared. So this is going to equal 120 plus 6 squared is 36, and by 5 gives us 180. So adding gives us 300. So our answer, the distance from P to Q, is working out as 300 meters.